Bismillahirrahmanirrahim. In this lecture, we consider the case of continuous variable and will learn how to find the frequency distribution of this variable. For understanding, we take an example about the marks obtained by the 60 students. There are few steps in constructions of frequency distribution. First step of the frequency distribution is to determine the minimum value and maximum value of the data. Now you can see that from the above data, 30 is the minimum value which is represented by x minimum, and 94 is the maximum value of the data and is represented by x maximum. The second step is to find the range by subtracting minimum value from the maximum value. So we have 64, which is the range of our data. The third step is to decide the number of classes and find class interval. Here number of classes is represented by k and class interval is represented by I. There is no hard and fast rule to decide the number of classes. Although some guidelines in different books are given about the number of classes, but that cannot be recommended in general. Basically it's an expertise of an individual on the basis of range and the number of observations. To understand the concept of this step, we consider an example. Suppose you have a large number of different books, registers, files, magazines, and small dictionaries, and you want to arrange them in a shelf. If you keep the whole stuff in a shelf containing only one step, so it is not a good idea because it will be difficult for you to differentiate among the types of different books. On the other hand, if you keep the whole material in such a shelf which contains too many steps, it is also not a beneficial because you may need more than one step for same type of stuff which is meaningless. So what is best strategy? The best strategy is to use a shelf with moderate number of steps of shelf. In this way, we can place similar stuff in a single separate step of shelf and one can easily trace the required book, file, magazine from the shelf. Like different types of books, data also not organized when initially collected, and we want to organize them in such number of classes so that similar data can be placed in a single class. So it is important to decide moderate number of classes. Generally, we decide the number of classes between 5 to 20. We decided to take the 7 number of classes for our data. Now, we are able to find the class interval by dividing range with the number of classes. So, we have 9.14 as an interval value, but you must take the next higher value in case of fractional intervals. As I mentioned with the red note that never round off, always take the next higher value. In third step, it's your choice either to take number of classes first and then find the class interval, or decide the class interval first and then find the number of classes. Generally, standard number like 5, 10, 50, 100 are preferred for class interval. Here we take interval is equal to 10. So by dividing range with the class interval, we get 6.4, but we will take the next higher value which is equal to 7 as number of classes for our data. The fourth step is to decide the lower limit of the first class. Choose either the minimum data value or any standard value below the minimum data value as the first lower class limit. The fifth step is to find all other class limits and allocate the frequencies using tally bar method. Now we start to make the frequency table from above given data. First of all, we make a table consisting k plus 2 number of rows and 3 columns. As we know, k, the number of classes, is 7 in our case, so we have 9 rows and 3 columns. In the table, first column is reserved for the class limit, second is reserved for the tally bar, and third is reserved for the frequency. After making table, we decide about the lower class limit of the first class. As 30 is the smallest value from the above data, further it is also a standard number. So lower class limit is 30. After adding the class interval in the 30, we get 40, which is the second lower class limit. The upper class limit of first class is always be the previous value of the lower class limit of second class. 39 is the previous values from 40. So this is our upper class limit of first class. To understand this, suppose the whole data is in fractional form. So the smallest value is 3.0. It is our lower class limit of the first class. By adding interval 1, we get 4.0. And the previous value of 4 is 3.9, which is the upper class limit of first class. So now we come to the main questions. To find the other class limit, just by adding the class interval on both sides, we get the class limit of our frequency distribution. Now, after completion of the class limits, we come to the tally bar of the frequency distributions. In the above data, 76 is our first value. So by crossing 76, we trace the class in which this value is lies. So the class is 70 to 79. So we mark here. Similarly, 72 is also fall in the same class. 58 also 58 fall in from 50 to 59. 60 goes to the class of 60 to 69, 72 goes to the class of 70 to 79, and so on. But keep one thing in your mind, that every fifth tally bar will be placed over the existing 4 tally bars in the respective classes, so that one can easily count the number of tally bar for that class. In the same way, the whole data will be brought into the relevant classes. The next step is to count these tally bars and mention the number of these tally bar in the frequency columns. The first class has 2 tally bars, so the frequency is 2. The next has 7 tally bars, so the frequency is 7, and so on. Third is 10, fourth is 21, fifth is 11, six, and seventh is 3. So the total number of observations are 60. This is frequency table or frequency distribution. You can see that there are different groups from the above data are nicely managed in the different classes in the form of frequency. So what we can learn from this frequency distribution or this frequency table, you can see that the number of poor performance students whose score are less than 50 or those students whose score are more than 80 are relatively smaller than the number of students whose scores between 50 to 59, 60 to 69 or 70 to 79. So the frequency distribution revealed that the class is an average class, not extremely good class or extremely bad class. Finally, we can remove the column of the tally bar to get the final shape of our frequency distributions, which consist only the class limit and the frequency of the respective classes. In this table, we will learn how to find the relative frequency, class boundary, midpoint, and cumulative frequency of a given frequency distribution. So the frequency distribution is given in the first two columns of this table. So in third column, we will find the relative frequency. Relative frequency is the ratio between the class frequency and total frequency. So the relative frequency of the first class is equal to 2 by 60, which is equal to 0.08. Similarly, the relative frequency of the second class is 7 divided by 60, which is equal to 0.12. So and so on. But keep one thing in your mind, that the total of the relative frequencies must be equal to 1. In the fourth column, you will learn how to find the class boundaries from the class limit. First of all, subtract the upper class limit of first class from the lower class limit of the second class, and then divide it by 2. Whatever the answer is, subtract that answer from all lower class limits. In this way, you will get the lower class boundaries. And then add these answers to the upper class limits to get the upper class boundaries. Here you can see that 39 is the upper class limit of first class and 40 is the lower class limit of the second class, and then subtracting 39 from 40 and dividing it by 2, we get the answer 0.5. So we subtract 0.5 from 30 to get the lower class boundary of first class, and by adding 0.5 to 39 to get the upper class boundary of the first class. In the same way, all lower class boundaries and upper class boundaries can be found. In the fifth column, we will find the midpoint or class marks. Midpoint and class marks can be used alternatively. Midpoint is basically the average of these, the lower and upper class limit, or average of the lower and upper class boundary. Just add the lower and upper class limit and divide it by 2, or add the lower and upper class boundary and divided it by 2. We get the answer. In the last column, we will find the cumulative frequency of the frequency distributions. First cumulative frequency is equal to similar as the frequency of the first class, which is equal to 2. But the second frequency of the cumulative frequency of the second class is equal to the sum of the first two classes. The cumulative frequency of the third class is equal to the sum of the frequencies of the first three classes, and so on. In this way, we can find all the cumulative frequencies for all classes. The last cumulative frequency must be equal to the total frequency, which is equal to 60. Now we consider another example of one decimal fractional data, which is the amount of rainfall from 1965 to 2006 during the month of February in Los Angeles. First of all, we will find the minimum and maximum value. So the minimum value is 0.0 and the maximum value is 13.7. In the second step, we will find the range. So maximum minus minimum, we have 13.7, which is the range of our data. In the third step, we decide the number of classes and then find class interval. Suppose the number of classes is equal to 5 and our interval will become 2.74, but we will take the next higher value because we never round off the values, but we take the next higher value. Students always face the difficulty in this step when they decide the number of classes and find the class interval. So therefore I show a table on the right side for different choices of the number of classes and the respective size of interval. So you can see that if we take the number of classes 5 and in this way we have our fractional value of the interval is 2.74. So this value is very close to the 3. So we take the interval 3. So this is a good choice. In the second step, you can see that if we decide the number of classes is equal to 6, in this way our interval is equal to 2.28, which is far from 3. So this is not a good choice. Another better choice is if you keep the number of classes equal to 7, in this way you will have the fractional interval size equal to 1.96, which is very close to 2. So with size number of classes 7 and size of the interval 2, it is another better choice of constructing a frequency distributions. All other possibilities of number of classes like 8, 9, 10, 11, 12 and 13 with interval size 2 are not appealing for frequency distributions. So it's better to avoid them. The last choice is 14 with one class interval. So it is too many number of classes. So it is not better to choose the 14 number of classes for this problem. So avoid it. The fourth step is to decide the lower limit of the first class. Choose the smallest value of the data or any value, standard value, which is below the minimum value of our data. The fifth step is to find out the other class limits and then allocate the frequency using tally bar method. After making a blank table for frequency distributions, we decided to take 0.0 as the lower limit of first class because this value is the smallest value of the data as well as it is also a standard number. The lower limit of second class can be obtained by adding the size of interval, which is equal to 3. So the lower limit of second class is equal to 3. Now we come to the upper limit of first class, so which is the always be the previous value of the lower limit of second class, which is equal to 2.9. Next, you just add the size of interval 3 successively in lower limits as well as in upper class limits to find out the remaining class limits. Now we come to the tally bar column. The first value is 0.2 and it also lies in the first group of class limits. Second value 3.7 falls in the second group of class limit. The third value 1.2 falls in the first group of the class limits, but the fourth value 13.7 falls in the last group, and so on. Similarly, we bring all the data in tally bar column. Finally, we count these tally bar for each group and then mention that number in frequency column. The first group of class limit has 21 bars, so the frequency is equal to 21. Similarly, second class has 11 tally bars, so the frequency is equal to 11, and so on. The sum of frequency is equal to 42, which is equal to the total number of observations of the data.